Welcome back. So we are going to continue today in physics class. Today we are discussing forces and motion. Forces and motion. What is a force? But before we define a force, what is motion? Motion is the change of position of a body with time. The change of position of a body with time. I'm a body. So the change of my position with time is what you call motion, and I'm going to demonstrate that. Let's call this what? Point A, or position what? A. And let's call that what? Position B. So if I move with respect to time, the change in my position with respect to time is what you call motion. But what causes motion? Force is what causes motion. Force is what causes motion. How do we define force? Force is the agent or the influence which causes a stationary object to move or stops a moving object or change the direction of a moving object. I will take that again. Force is an influence or an agent which changes the state of rest of a body or causes a body moving in uniform motion to stop or change the direction of motion of a moving object. So today we are going to demonstrate a lot of things about force. There are two types of force. We have contact force and field force. What are contact force? Contact forces are forces which are in direct contact with the body in which they act upon. I'm going to take up again. These are forces in which the body is in contact with the source of the force. Example is push, pull, tension, that means forces in rope, friction, and normal reaction. I'm going to take them again. Examples of contact force. We have push, we have pull, we have friction, tension, and normal reaction or reaction forces. But field forces, these are forces in which the body does not need to come in contact with the source of the force. The body does not need to come in contact with the source of the force. Examples, we have magnetic force, electric force, gravitational force. But let's look at what? So many things about force and motion. One thing you need to understand that forces causes what? Object to accelerate. Forces causes what? Object to accelerate. So let's look at what? In the area, let's look at the area of acceleration and friction. So this is acceleration. So you can see on the board here we have the forces, we have sum of forces, we have the values, the masses, the speed, acceleration. We have friction, we have the body, we have the other body. So what I'm going to do here is to increase the mass of the object we have here. This is 50 kilograms. I'm going to change it to 200 kilograms now. Now, so we're going to apply, this is the applied force, like push or pull. I'm going to what? Apply a certain value of what? Force to it. Now look at it. You can see the object is not moving. Why? Because the applied force has not what? Over what? Come the frictional force. You can see now the object is accelerating. Now the object is moving, is accelerating. Why? The applied force now has overcome the frictional force. But I'm going to show us the values of the speed, acceleration, because these are terms that we use in motion. Velocity, acceleration, speed, displacement, distance. These are terms that we use in motion. So I'm going to show us so many things now. So this is the word speed. This is the acceleration. This is the word object that is being pushed. This is the word body pushing the object. We have the sum of forces. So I'm going to apply what? A certain value now. You can see the applied force is moving towards this direction. The frictional force is moving towards this direction. I'm going to what? I'm going to keep applying, increasing it. And you will see the body will start moving now. Just a moment. Now, started moving. Can you see that? Now, do that again. This. Let's introduce this back. Now we have, let me show them again. Okay, so look at this. Now you can see that the net force is 77 Newton. The applied force is 445 Newton. The frictional force is 368 Newton. Now I know you want to ask, sir, you mentioned friction. Now there is friction here. What is friction? Friction is the opposition to the relative motion between two surfaces in contact. The opposition to the relative motion between two surfaces in contact. So that is why the friction depends on the normal reaction. And for this kind of body, the normal reaction is equal to, demonstrate this again. So we have 200 kilogram body. So let me bring this back. And you can see the forces, sum of forces. We are going to be showing this. This what measures the speed. The acceleration will be what also be shown here. So now let's look at this together. I'm going to apply a certain what amount of force. Keep applying, increasing the applied force. Now you will see the body will start moving. Can you see? The body is moving. So we can see that the applied force is 445 Newton. The frictional force is 368. The net force, that's the what? The force that causes the object to accelerate. That's the reason why it's moving. Is what? 77 Newton. I'll take that again so that we can see it clearly. I'll be shaking now. Okay. Because I want us to look at, you can see 77, 76, like that. Look at the speed. The speed is increasing. Why? Because I'm increasing the net force. So the more I apply more force, what happens? The net force keeps increasing. And it is this net force that causes the object to accelerate. Why? So the value for the net force, to get it, is mass of the object multiplied by the acceleration of the object. So I'm going to demonstrate another thing for us today. So let's look at another example. We are going to change the body now. We are going to change the 200. We are going to change the 200 kilogram body to 50 kilogram. So we will see that the value for the first applied will be a little bit lower than the previous 200 kilogram body. So we will look at this. So you can see. You can see now. When the applied force is 165 Newton, look at the frictional force. Look at the rate at which it's moving. So you can see the acceleration. The acceleration is 1.22 meters per second. You can see that the speed is increasing. So this is what I'm telling you. You can also measure the acceleration. You can also measure. So thank you for attending the class today. The assignment for today. So I have the following assignment for you. Now these are the assignment I have for you today. State 5 laws of solid friction. State the 5 laws of solid friction. Also, write down the formula for force. Write down the formula for force. In addition to that, state the 2 types of friction. Thank you for attending today's class. Bye.